In this video, we will solve a confidence interval problem. This particular problem, we will get fcalc to be greater than ftab. And so let's get started. So we have a concentration of X, and we get it from two sources. Source A from one location and source B from another location. And so concentration of X was, the average was 0.025 plus or minus a standard deviation of 0.1. And for B, we had 0.037 plus or minus 0.02. For A, we took 4 measurements, and for B, we took 10 measurements. So in this problem, we want to know, are 0.025 and 0.037 significantly different from each other with a 95% confidence? And so the first step that we're going to do is determine fcalc. And so that's going to be the standard deviation squared divided by standard deviation squared. Fcalc must be greater than 1. So if we choose 0.02 squared divided by 0.1 squared, it's going to be a very small number, less than 1. But if we choose this to be standard deviation 1, we would get 0.1 squared divided by 0.02 squared, which is equal to 25, which is bigger than 1. And because of this, we call this standard deviation 1, and we call this standard deviation 2. Meaning, this is standard deviation 1, so this is average 1, and this is N1. This one right here is standard deviation 2, so this is average 2, and then this is N2. From here, we will use two formulas to ultimately determine whether these two numbers are significantly different or not. But before we do that, we need to determine ftab. So degree of freedom for S1 approaching 3, meaning, so degree of freedom, we look at N. This one, N is equal to 4. We subtract 1, we get 3. Here we get 10, we subtract 1, we get 9. This is the degree of freedom. If the degree of freedom for S1 is equal to 3, and the degree of freedom for S2 is equal to 9, then ftab is 3.86. This information would be given in a table where you would have other pieces of information. And because of that, you see that fcalc is greater than ftab. And whenever you have situations like these, there's a particular way to solve this problem. And so let's do that. So whenever you have fcalc is greater than ftab, the formula to calculate tcalc will be this, is equal to the absolute value of average 1 minus average 2 divided by the square root of standard deviation 1 squared divided by N1 plus standard deviation 2 squared divided by N2. And so we would get the absolute value. So X1, the average was 0.025 minus X2, which was 0.037. And so this piece of information right here was given in our table. So X1, and then this was X2. We said that this was X1 and this was X2 because this we determined to be standard deviation 1. Therefore, this will be average 1, and this will be N1. Divided by the square root, so standard deviation 1 squared, which was 0.1 squared, divided by N1 was 4, plus standard deviation 2, which was 0.02 squared, divided by N2, which was 10. And so we would get for tcalc as 0.2381. Next, we need to get the degree of freedom for using t-table. And the degree of freedom isn't known because fcalc is greater than ftab, and this means that the standard deviation is very different, and so we need to calculate the degree of freedom. And so there's another formula for that. So the degree of freedom is equal to the standard deviation 1 squared divided by N1 plus standard deviation 2 squared divided by N2, close parentheses, and then we square it, divided by parentheses, standard deviation 1 squared divided by N1, close parentheses, we square it, but divided by N1 minus 1 plus parentheses, standard deviation 2 squared divided by N2, close parentheses, we square it, divided by N2 minus 1. And so this right here would equal parentheses Standard deviation 1 was 0.1. We square it, divided by n1, which is 4, plus standard deviation 2 squared, 0.02 squared, divided by n2, which is 10, close parentheses, then we square it, divided by, so standard deviation 1 squared again, so 0.1 squared, divided by n1, which is 4, close parentheses, we square it, divided by n1 minus 1, so 4 minus 1, plus parentheses, standard deviation 2 squared, 0.02 squared, divided by n2, which is 10, close parentheses, divided by n2 minus 1, so 10 minus 1, and you also need to square this piece right here, and so this right here would equal 3.1, so we can say about 3. And so whenever degree of freedom is equal to 3, we get a value of 3.182 for the confidence of 95%. And this we will call t-tab. And so we can say that t-tab, t-table, is equal to 3.182. And if you notice, t-calc was 0.2381, but t-tab was 3.182. And so this shows that t-calc is less than t-table. And because of that, it's not significantly different. So whenever t-calc is less than t-table, we say it's not significantly different. And this is just a recap. If f-calc is greater than f-tab, then what we did is correct. But if f-calc is less than f-tab, you need to do something different. And in my previous video, I show you how to do that. So this is very important, that f-calc is greater than f-tab, then what we did is correct. So you would do t-calc like this, then you would do degree of freedom like this. From here, you get the value of t-calc and t-tab. If t-calc is less than t-tab, it's not significantly different. But if t-calc is greater than t-tab, then we say it is significantly different. And just to specify, we say not significantly different at 95% confidence. Because we want 95% confidence and our table was for 95% confidence. And that's all we need to do for this problem.